Welcome to the future, where a skilled, committed workforce using state-of-the-art equipment and processes is dedicated to producing aluminum metal castings that surpass all previous standards. The Windsor aluminum plant is the most advanced facility of its type in the world, and it's the people who make the difference. The facility began as an advanced research and development center located in Windsor, Ontario. After years of refining its production process for manufacturing the advanced design blocks, the Windsor aluminum plant was finally built next door to the original R&D site. It has now become the primary supplier of aluminum engine blocks for Ford Motor Company. The revolutionary vision for the new facility was to create a plant that would mass produce the highest quality cylinder blocks known by transferring the low-volume, precision casting Cosworth process to a high-volume operation. The casting technology pioneered by Cosworth Racing has been proven throughout the world in Formula One engines. Ford engineers worked to develop an efficient, high-production, low-cost process from the Cosworth sand casting process and improved even further its precision sand casting capabilities. These efforts paved the way for the manufacture of Ford's new generation of lightweight, high-output, and environmentally friendly engines. Today, Windsor Aluminum produces the 2.5-liter V6 cylinder block used in the Mercury Mystique, the Ford Contour, the recently redesigned Mercury Cougar, and the Ford European Mondeo engines. The plant also produces the 3-liter V6 cylinder block used in the Mercury Sable and the Ford Taurus engines. The 3-liter Doo Jaguar V6 cylinder block used in the Jaguar X200 and the Lincoln LS. The 4.6-liter V8 cylinder block used in the front-wheel drive Continental engine, and the 3.9-liter V8 cylinder block for the soon-to-be introduced Lincoln LS with a V8. And true to its original vision, staying on the cutting edge has become the tradition at Windsor Aluminum. In fact, the Windsor Aluminum plant has set new standards for the entire automotive metal casting industry.
Windsor Aluminum has implemented many unique and innovative technologies that make us stand out and prove our commitment to producing the best engine blocks and creating the best work environment.
These include core package rollover, thermal sand removal and reclamation, cast-in liners, serialization of product, core talc application, 100% vision system inspection, 99% automated handling, voice recognition data collection, and ISO 9000 and ISO 14000 certification.
And new processes are continually being evaluated to improve productivity and quality.
Here in the core making area, mold patch components are made and assembled into the final core package.
Sand is loaded into core machine hoppers from sand cars traveling above the assembly cell line. The cars travel back and forth to the main supply for refilling, and assembly cells call the car as sand is needed. Molds are made of zircon sand, brought in exclusively from Australia because of its unique particle size. This natural occurring mineral is expensive at $400 to $600 US per ton. Due to its exceptional thermal stability, neutral buoyancy in molten aluminum, and faster cooling rate, it is used instead of silica sand. Empty carriers arrive at the core assembly line accompanied by the cylinder bore liners. Robots remove the liners from the carrier and place them in the core box tooling. The sand is blown around the liners and bonds itself to the metal surface. This innovative production technique, pioneered by Windsor Aluminum, installs the liners into the core package so that they will be cast into the engine block. Core pieces are dipped in talc before they're assembled. The talc causes the sand to be completely released when the casting passes through the sand reclamation furnace, and a smooth casting finish is the result. The vehicles carrying the core packages and traveling on inverted monorails are equipped with programmable logic controllers so that cores can be tracked as they are assembled. These carriers are equipped with safety bumpers and infrared proximity sensors so that they do not present a hazard to the workforce.
Most of the components of our core package are held together through a sophisticated interlocking system. A few, however, are attached through a hot melt glue system applied by our robots.
Windsor Aluminum is the only casting operation to produce a serialized product. Prior to the implementation of this patented technique developed at Windsor Aluminum, castings were identified by day and shift only. A mechanical scriber etches the reverse image of the serial number into the resin-coated sand. This results in raised numbers on the casting. The prestigious Henry Ford Technology Award was presented to the personnel of the Windsor Aluminum plant for this innovation. Patterns, or core boxes, are changed automatically by robots. Changeover time is typically less than 15 minutes, a significant improvement over the more time-consuming manual changeover method. Dry ice pellets are used to clean the tooling during an assembly cycle. Since the CO2 evaporates immediately, this is a great improvement over shot blasting, which requires extensive cleanup. When the number of core packages required to fulfill an order has been built, the tooling for that block is dipped into an ultrasonic bath for a more thorough cleaning before being put into storage. After final core assembly, the package is transported to the induction heater unit. A final 3.9-liter V8 sand package weighs approximately 360 kilos. The 2.5 3-liter sand package weighs approximately 250 kilos. Induction heater coils are inserted into the core package. This heats the cylinder liners to a temperature which ensures that a secure bond is formed when the liquid metal is poured and cools. Cast-in liners have a much more consistent bond than traditional force-fit liners. This process ensures complete adhesion of the aluminum to the iron liner. Aluminum ingots are melted in the two main gas-fired furnaces, each of which holds 41,000 kilos of molten metal. If molten aluminum is exposed to air, it causes porosity and hard spots in the casting. To avoid this, the molten aluminum is contained and poured in a closed system. Instead of being transported by fork trucks in open ladles, the molten metal flows through sealed conduits called launders into the pouring furnace. This process not only improves the quality of the castings, it significantly improves the safety of the working environment. The pouring furnace holds 32,000 kilos of molten aluminum. Here, the aluminum is maintained at the pouring temperature throughout the delivery system. In the heart of the plant, molten aluminum is pumped into the mold package using an electromagnetic pump. This pump, which was adapted from the aerospace industry, has no moving parts and produces a uniform fill rate that ensures that the oxidized surface of the molten aluminum will not rupture during the fill process. The mold is filled from the bottom with the molten aluminum. The pour rate is controlled by an electronic feedback system to ensure the molds are correctly filled. Because the hottest aluminum is then at the bottom, the mold is automatically rotated 180 degrees. This prevents convection currents from forming, resulting in a significantly higher quality casting.
Rollover was a Cosworth theory that was never tested. It was at the original Windsor R&D Center that it was tested, researched, and applied to a production setting.
A computer system integrated into the rollover station provides feedback on each mold fill. Several pouring process goals must be met to ensure a quality casting. Robotic load and unload of rollover packages was developed by engineers at the R&D facility and refined at Windsor Aluminum. The rollover core package is immediately transported to the thermal sand removal and sand reclamation area. During its 4-hour ride through the thermal sand reclamation unit, or TSR, the blocks are heat treated, causing the core binder to break down and release the sand, which falls to the conveyor below. The sand is filtered and cleaned. A phenomenal 99.8% of this expensive sand is reclaimed, thus saving production costs and eliminating landfill disposal costs. When the block is unloaded from the TSR, the risers are cut off and the block is shot blasted. After shot blast, the V6 blocks are transported using an overhead electrified monorail system to the material handling for heat treat system. This system uses a state-of-the-art vision system in complement with intelligent real-time robot loading of cylinder blocks into shipping racks. These are then loaded into trailers and sent to the vendor. The V6 blocks are heat-treated in order to maintain a high degree of dimensional stability during service. The castings are returned in the same racks and are loaded into the material handling system. The same robot system visually locates the castings and visually checks for a paint mark, verifying that the block was heat-treated. The system then loads the cylinder blocks back on the monorail system, and they are sent to the finish area. A smart monorail robot system transfers blocks to the finishing area. 99% of handling throughout the plant is performed by robots. Castings are machined and tested. The V6 cylinder blocks are rough machined on a fully automated transfer line. State-of-the-art vision system inspection techniques have been implemented on the V6 finishing line. The video image of each block is recorded and computer analyzed to assure quality. This is followed by manual inspection for additional characteristics. V8 engine blocks are rough cut at computer-controlled machining centers.
This is a milling machine for the Jaguar blocks. The blocks are loaded and all tool changes are done automatically. The blocks are completely finished in one cycle.
At Windsor Aluminum, all cutting is done dry, that is, without coolant. It's the use of coolants that contributes to the grimy environments associated with more traditional machining operations.
Cleaning is paramount here. When people come to visit, they expect to see a grim, dirty casting machining facility. But not here. Cleaning is our priority.
As further proof of the rigorous inspection philosophy, every block is rough machined a few millimeters on 6 sides to ensure a quality casting.
Elsewhere in the industry, this step is performed by engine assembly plant. But we are determined to guarantee shipment of only the highest quality cylinder blocks, so we go to these lengths.
The drive for quality is intense. Numerous inspection techniques are applied throughout the process. All blocks undergo air testing for soundness and are sampled for hardness. Regular dimensional analysis is performed using coordinate measuring machines. In-house scrap data is collected via a voice recognition system and analyzed. Windsor Aluminum has been a forerunner in the installation of factory floor computer programs to increase efficiency. For example, it was one of the first facilities of its kind to install a human-machine interface.
The human-machine interface is a computer program which is loaded to all the machines throughout the plant. It allows for machine malfunctions to be displayed in words so that the operator does not have to call the computer specialist.
PC workstations with touchscreen are located throughout the plant. These computers provide machine monitoring information, preventative maintenance scheduling, and the ability to locate and order crib items.
At Windsor Aluminum Plant, we're proud to be the benchmark in terms of environmental responsibility. We recycle waste throughout all processes of our plant, and that includes zircon sand recycling. The core binder hardening catalyst, triethylamine gas, is collected by scrubbers and is also sold for recycling. At Windsor Aluminum, we're proud of our initiatives and continuous improvement in environmental responsibility.
The neighboring Casting Process Development Center, built to develop and test new manufacturing methods, continues to be an invaluable resource for Windsor Aluminum. A participative management system moves away from the traditional approach and helps remove barriers. Health and safety are priorities. Ergonomic and environmental issues were considered and planned for in the early design stages of the plant. Core loading, for example, and most material handling is automated. This forethought and the continuing attention to creating a healthy, clean, positive work environment is confirmed by excellent health and safety records. Training is ongoing and makes it possible for employees to be active in plant operations. Training is provided in many areas, including health and safety, computers, quality, technology, interpersonal skills, and business. We believe a skilled workforce is the cornerstone from which we can build innovation and quality. Recognizing individual merits and interests and inviting the community into our facility are other important ways we support and build our team. United Way drives, thriving student co-op programs, and joint venture research projects with neighboring colleges and universities are some of the ways we strive to contribute to our community.
As we progress into the future, here are some of our achievements along the way. Henry Ford Technology Award, Q1 to QS 9000 standards, ISO 9000, ISO 14000, first casting plant in North America, and a 1998 Customer-Driven Quality Award finalist. We know that innovation and a committed workforce are the keys to achieving our goal of producing the world's best aluminum castings.